So this one was called a balance problem because the total supply was equal to the total demand. Well, that was kind of like, that was lucky. It's kind of like, typical textbook problem. Okay. So if I add up the supply, I get 13,500. If I add up the demand, I also get 13,500. Just happen to be equal to each other, and I also kind of put it in here. So we also want to know what to do when the two amounts are not equal to each other. Okay. So let's see. So let's talk about one case today, and then next time we'll talk about the other case. So let's talk about the easier case today. So the easier case is when you have more than enough, right? That's an easier case. So total supply is greater than the total demand. Then that's no problem there. So the next one here, next sheet is it says Foster optimal number 2 has that case when the total supply exceeds the total demand. Okay, so this is kind of what we get. But what I want to do is I want to change the original solution, original model, so we could kind of see what changes we have to make. So what we're going to do is here, I'm just going to the original solution, and here I'm going to just change this number. So this number, suppose we have 6,000 here instead of 5,000. So suppose here we have 6,000, so that is now the total supply will now be greater than the total demand. Okay, so here I'm going to change it to 6,000 here. Now I could see that total supply is 14,500, no, 1,000 more than the total demand. So then what do we have to do anything differently here? Do you think we have to do anything differently? So that's the 6,000, so we have more than we need. And then let's look at the constraints. Less than equal to, so basically here it's saying that total amount shipped out could be less. When you look at these constraints, total amount shipped out could be less than, It doesn't have to be equal to the amount that's available. So having more than enough is not going to be a problem here. So all I have to do is here, change this number, and then just solve it again. First order, and then solve. And so now here's my new solution. That's it. So here's my. So what is this saying here? So now I have some different numbers here. Okay. So like here we could see before we had here we had 1,500. Now we have 2,500. Okay. Let's see. Here, yeah, this one now turned into 2,500. And here this was, so these numbers switched. So you used to have 1,500 and 2,500, and those two numbers switched. It's kind of like to take advantage of this opportunity. So first, Cleveland has 1,000 more than before, so there's more leeway, so you could kind of shift things around more. So perhaps we could save a lot of money, and that's kind of what happened. Okay, so now the total cost is 36,500. 36,500, and all the constraints are satisfied as you would expect. So that's my new solution, and that's what you see here in the total. It says optimal number 2. Okay, so that's that case. The total supply is greater than the total demand.